Okay, can you hear me now?
Yeah.
Okay, so I think I'm changing up the pace of this a little. I think the next 45 minutes will be dedicated to redfish and cooling. It'll be started by 15 minutes of me trying to do a quick brief of what redfish is, and then followed by 15 minutes of redfish for cooling, which Michael Thompson will provide on how he's been able to utilize redfish to start defining manageability for cooling. And then there'll be a 15-minute Q&A starting at the top of the hour, uh, um, covering QAs about redfish and cooling. Okay. So I'm John Leung. I'm the OC representative at the IC to the Hardware Management Project, and that's where we've instilled the Redfish as the hardware manageability interface for OCP platforms. Oops, gotta build this puppy. Okay, so what is Redfish? So Redfish is owned by a standards body called the DMTF. It is a modern RESTful interface for manageability. Basically, we went out to the data centers and asked them. This is not the first time DMTF has done manageability. We've had other protocols. This time we went out and we asked the data centers what would make you use the management interface that we defined, and they basically said. Right now, whether it's IPMI or your SIM-based model, it requires that we have dedicated people. We have to either find them and hire them, or we have to train them ourselves. Most of the people that we train see these arcane languages and protocols as a career dead end. So what we really like to do is have an interface which is based on technology that we utilize, which is the web protocols, the structures, the data models, the tool chains. Um, and you can start with something RESTful, something with HTTPS. And if you do that, then we can take people off our mainline development, have them do manageability for a while, and then when they're done, they can go back and do our mainline and make us some money. We took that to heart. So in 2015, we released Redfish, and we've been building momentum through various organizations ever since. So what does Redfish do? Redfish does so it's based on these uh, standard protocols that we have. It is an accessible client-side code. So we provide schemas for all the models that we generate so that you can auto-generate client-side code for it. It's released as JSON schema. It's released as Open API, and it's also open released as OData CSDL. Um, and that way, there are a lot of code generators in both of those tool chains that you can use and just generate client code to go execute against a Redfish server. So what we've done in short is we've taken manageability and we reduced it to URI, which is a path to a resource, and then a structure for the JSON response that you get back when you do a get on that response. Um, so at the end, you can go write a line of code on curl and do an access to HTTP access to a Redfish service. You get back some Python code. You pump your Python through. You get some JSON, you pump it through some Python code, and out you can pop whatever name value pair you want. So in this case, it's the serial number, and you output a serial number. Since we released it in 2015, I think 3 years later, it became an internationally recognized standard by ISO. And we are kind of in the process of actually upgrading that since it's been several years since we've updated the international spec. So I know this is a nitrite, don't worry about it. As I said, we've reduced manageability to basically an HTTP request, which would be this, which is a get. And the only reason you have this diagram is to show you exactly what you do within your path. So Redfish V1 would be service root. You want the first system on it. So you would do systems and then CS1, which is computer system 1. If you wanted the information on the second processor, you would go put slash processors /2, and you would get an information JSON packet in response, talking with all the details about your particular processor. So what I've shown here is just the JSON response for a computer system. And without going through all the details, these JSON is basically a set of name value pairs. So there are a simple set of properties, which are listed here. There are complex properties, which are basically structures of simple properties. And then there are subordinate resources, which are resources that can only exist, which are subordinate to computer system. So these are all subordinate, which means that if the main system, just one were to disappear, then these would all get deleted also. And then complementary to the subordinate resources or associated resources, which are resources that exist regardless of whether this primary resource exists. So managers for it and the chassis in which it resides are associated resources. And that's what these links actually point to, because they will exist regardless of whether CS1 is deleted or not. And then finally, we have actions. So not only do we have our full suite of get actions, but you can also post to a resource and actually get it to do stuff. So in this case, you post to an action to reset the system, and the JSON itself will tell the client exactly what to do. So this tells you the target, which is the target of your post. So just do a post to this particular URI, and the system should reset. And since resets are not as simple as they sound, that there are these reset types that you can do simple resets, you can do power offs, you can do a graceful shutdown of the system, that you might want to pass this type of information across in your reset post. And so all that is collected in reset action info, which tells you what properties can be added into the post request in order to provide additional communication in your reset. So very much like passing a parameter to a function. So in this case, if you actually look at the file, there's only one property. It's called reset type, and you can set it to various values. So having done that, this is just a collection of an early snapshot of the capabilities with the Redfish model. So in addition to all the stuff that you can do it on chassis, you can view it on computer systems and management infrastructures. So instead of IPMI, which is current functionality, which only dealt with single systems, Redfish is built or designed to deal with full racks with multiple systems on them. And that's why we have all these collections everywhere, so we can enumerate the collections in the model and associate relationships between them. Because it's HTTP, we can take the HTTPS model for security. We also have roles and privileges, and we have a asynchronous method of getting events. So you can subscribe to events that are generated asynchronously by the Redfish service. So about 2 years ago, I brought this to OCP. OCP had made the decision to use Redfish as the structure for manageability. The original intent was for hardware management to do a baseline profile, and then each platform would go ahead and extend that with additional functionality for servers and for storage. So the hardware baseline would define a set of common manageability across all OCP platforms, and each platform group would go ahead and extend it for their specific one. Rack and Power has actually provided one, which we'll talk about in the next presentation regarding what their profile is. Make sure okay, 4 minutes. So what can you do with these profiles and why is it useful? So a profile, basically, once we've defined a set of resources and properties that define a model, the DMTF's job is to be descriptive. It tries to describe as many things as possible, and in so doing, it defines compute model within DMTF, went to the SNIA standards body to define storage, went to AshRay and TGG to help us extend into power and thermal and DSIM platforms. So we've constantly trying to find actual subject matter experts in other areas to continue extending the model. So what the profile does is it defines the subset that OCP would want in a particular implementation. So it defines the resource property, the value of the resource property, if that's what you want to specify, and then it's all written in a JSON format. Redfish also wrote the Redfish interop validator, which actually consumes this profile file, auto-generates the test and executes it, of course, against a conformant implementation. So if you've built a system and you believe it supports all these functionalities, we now have a test suite to actually to run against it. That test is part of a OCP conformance suite, which tests, the first two tests test the protocol of the HTTP itself and the services which are required by Redfish, and the interop validator is the one that tests the actual model that you have on the other side of your protocol. On the bottom, these are all open source, and so in the bottom is the GitHub where all these tests are placed for people to use and comment on and give us bugs and issues on. So as I mentioned, we go to various other standards bodies and SMEs to enhance our models. When we released this in 2015, we had our power and thermal model. It was fairly simplistic, and we've learned a lot in our engagements with the Green Grid and AshRay. So we've incorporated the sensor model, and we basically redid the sensor model. We've added controls, and we're adding alarm models to our latest release. So we've done several releases of these revised models as work in progress. When I submitted this slide set, we had only released 0.8. In October, we released 0.9 because we're getting very, very close to the release. And so that's why that's updated. And we're constantly asking for feedback. As a matter of fact, we presented to in a joint meeting of OCP rack management and DC facilities in 2020 in September of this year, because as I've seen in previous slides, right, the immersion cooling affects not just the rack itself, but also affects the actual facilities. So the work in progress is also released, is public because as a work in progress, and we asked then and we ask now to continue providing feedback as you attempt to use the model that we have to model whatever you guys need in regards to cooling, and provide feedback if we're missing something, if we need to go add something. And so with that, right on time. So my call to action is stay for the next 15 minutes, because this Michael Thompson will actually make this relevant to you guys when he relates this the modeling that we've done to cooling. Continue to provide feedback on our proposed models, and for all this additional information, because I've gone through this very quickly, if you want additional information on Redfish, here are all the links to almost everything I've talked about in previous meetings. I will point out that there's a public discussion forum, which is the fourth item down, which is you need no membership. It is a fully public bulletin board where you can post any questions you want, and it's actually one of the first items that the Redfish forum addresses when they meet twice a week. Okay, with that, I will hand us off and then come back in 15 minutes and handle any Q&A.